Hello and welcome to this COMP533 video on sets, Venn diagrams and Cartesian products. In this video we will learn about the historical background and context of the topic, understand the basic concepts and meaning of the topic, use an example to better understand the topic and its applications, and then we will conclude with a recap. First, let's understand the historical background and context of Venn diagrams. In 1880, John Venn, an English scholar, wrote a paper called On the Diagrammatic Representations of Propositions and Reasonings, where he discussed multiple ways of visualizing relationships of sets through what he called Eulerian circles. Then, 38 years later, in 1918, Clarence Lewis later coined Eulerian circles as Venn diagrams in his book, A Survey of Symbolic Logic. Euler diagrams are still commonly used today to show subset relationships. A subset is a set that is part of a greater set. For example, animals would be the main set, while carnivores would be the subset. In simple terms, the purpose of Venn diagrams are to show the Cartesian products of sets. Cardinality is defined as all the possible products for the sets. Let's break this down and put this term into our word bank. A set is a collection of elements from numbers and points to data that appear in list form and are represented by curly brackets like these. Let's look at the Cartesian product in an example. For example, if we have set A and set B, and we want to find the Cartesian product for the sets, we would plot them on a Venn diagram. In our example, set A is on the left, while set B is on the right. Now let's use our Venn diagram to look at some common set operators. The union operator, denoted by this, shows both sets, while the intersection operator, denoted by this, shows the integers that appear in both set A and set B. This Venn diagram shows just set A, whilst this Venn diagram shows just set B. Next, this Venn diagram shows set B minus anything in set A, including the intersection, whilst the opposite is true for this Venn diagram, showing just set A minus anything in set B, including the intersection. Finally, this last Venn diagram shows anything that is not in set A or set B. Let's now look at what we've learned in an example. Let's say that we're looking at people that like dogs versus people who like cats, and we are given these sets. To put these sets into Venn diagram form, we would see the overlap between the sets and see that Emma liked both dogs and cats, and therefore she would go in the intersection. Anna and John would just be in the dog section, and Abby and Mark just in the cat section. If we wanted to find the union of the diagram, this would show all the people. The intersection function would just show Emma, A minus B would just show Olivia and John, and B minus A would just show Abby and Mark. In addition, if we introduce a third set, people who don't like either dogs or cats, we would put a box around our diagram and put them on the outside of the diagram to represent that they don't like either. Using Venn diagrams are a great visualization tool, as they are a simple way of displaying the similarities and differences among sets. Due to their simplicity, they are and can be commonly used in everyday life, from math problems to shopping items. Let's take a look at our word bank and recap over our key terms. Firstly, sets are a collection of elements that are represented in list form with curly brackets. Cardinality are all the possible products for the sets. The union operator shows all the sets, and the intersection operator shows the similarity between the sets. To conclude, in this video we have learned about sets, Venn diagrams, and Cartesian products. Thank you for listening, and I hope you enjoyed it.